and welcome to our seminar on addressing forward error correction challenges on your 400G device. My name is Steve Sequel. I am the 400G, 800G solution specialist here at Keysight Technologies. Okay, and here we see an actual quote from 802.3bs project in 400G Ethernet, where we're actually showing where a frame loss ratio is specified. And you see that it is, in addition to an aggregate burr, we have to measure an aggregate burr of 2.40 minus 4, and then we have some additional requirements for the frame loss ratio measurement. And why do we need that? Well, the reason we do is what we're really trying to search out for is burst errors that are going to cause the Reed-Solomon decoder to fail and lose the frames because we exceed the maximum number of correctable errors per code word. And that situation can occur in these real links when we use decision feedback equalizers. DFE is used quite often in these links because of the amount of eye closure that is present, and when DFE is not implemented properly, you have the possibility of actually propagating an error. So, one or two errors can go through and a whole burst of errors come out, and when that happens, that can overload the Reed-Solomon decoder, and that would not necessarily be caught in just doing a aggregate burr measurement. So that's the reason that the standards now require it, because of assumption of DFE. So how do we measure it? Well, the standards don't tell us what a test methodology is, but what is assuming was going to be done is self-test. And that assumption has some flaws in it that we'll see.